Hello students, this is Deepak Kumar and welcome to my first recorded lecture on this module, software engineering. We're going to talk about a very fundamental concept of software evolution in software engineering. So in this chapter we'll talk about why software evolution is a very important part of software engineering, and it will talk about different challenges that software organization or a software development team would encompass while maintaining a software and while going through different stages of software evolution. So we'll talk about what different type of software systems are available, and we'll talk about how the software change is an integral part of software engineering. We'll try also to understand different factors which are critical to drive software evolution or a change in the software while the software is being used in different businesses, in different environments, and the challenges that the software faces, or the challenges that would be deterministic of software change, which obviously is categorized as software evolution. We'll try and understand about the legacy systems. So a legacy system, what is a legacy system? How would you classify legacy systems, and how would you analyze them in terms of their usability, and in terms of the decisions to keep them or to maintain them, or whether they should be scrapped or they should be re-engineered, or what is the right time of replacing these legacy systems. We'll also talk about software maintenance, and obviously software maintenance is another aspect of software evolution. So let's begin. So as we know that software change is inevitable, new requirements emerge, and as there are changes in business environments, it could be changes in the environment in which a software operates. It could be the change in operating system. It could be the change in certain technologies or certain hardwares on which that system runs, and all that could lead to sometimes a requirement to change the software, and that leads to software evolution. So one of the key problems that every organization faces is how to manage that change, and how to keep on how to keep abreast of this requirement of software changes, and how do you inculcate these changes, how do you manage these changes, and how do you really make sure that the software remains relevant, remains useful, and it remains effective for any business, and it basically serves the purpose for which it was designed. Many times there are business rules that change, and changes in the business rule would obviously lead to user expectations to have a change in the software as well, to change the environment of the software as well. And that would also call for modifying the software to suit the new requirements. And it would be also to adapt to platform changes. It could be a requirement for changes due to a new operating system environment. It could be because the hardware needs to be changed, and as a result of that, the software that runs on it has to adapt or has to be modified in order to serve the purpose of still remain functional in a change environment. So these are some of the driving factors for software evolution that drives the software change, that drives the modification in the software itself. And as a result of that, many big companies constantly keep on changing their softwares, they keep on evolving it. And one of the studies from Linds and Swanson in 1980 actually says that between 60 to 90% of the software costs are actually incurred as the software evolution costs. So as we discussed that in software engineering process, which is anyway an iterative process, which is a spiral process which have multiple iterations of changes right through all different stages of software development life cycle, whether it is from requirements to design to implementation and to testing and finally to deployment of the software. We see that these changes do occur, but even after the software has been deployed, there might be a requirement for changing the software in the later stages. In old softwares, we have seen rather that these iterations were very long. They used to span for like long years because the changes were not that frequently required. But in today's scenario, there might be a iterative cycle which might be asking for a change every year, or probably even every month in certain cases. Say for example, a software needs a new security patch to attend to certain vulnerabilities or threats that are exposed and that become known to the community, and that becomes a threat now for the users of that software. So you may have to patch it as soon as you came to know about a particular vulnerability, and this is what the software manufacturers do. They release a patch to fill that loophole, to patch up that vulnerability that is being exposed. So that could be one of the requirements. It could be other set of requirements, which could be the competitive pressures, certain requirements from the user feedback which needs to be addressed pretty urgently, and these are some of the reasons which would be further driving the change or driving the software evolution. Normally, as we have already said, that certain organizations have very huge investments in their software systems, and they are their critical business assets. So to keep them still versatile and to keep them useful to the business, they have to be changed and they have to be updated, because business operating environments are ever changing, they are dynamic, new requirements come up, and maybe some new business rules are imposed, and as a result of that, the software has to change and the software has to evolve, and that automatically signifies the fact that a majority of the software budget in the large company is devoted to changing and evolving the existing software. So when we look at evolution, and since we are already aware of the software development life cycle, especially if it is we're looking at the agile approach, and we see that it follows a iterative model or a spiral model. So similarly, a software evolution also follows a spiral model of development, and this basically starts from gathering new set of specifications which would be required in terms of new requirements that have arisen from the change of certain factors, which could be something like change in the operating environments, change in the business rules, change in user requirements, or other different reasons. So basically this requires a transition from the development model to the evolution model, and the same concept which are very much used in software development life cycle actually also applies to the evolution or the maintenance aspect of software changes as well. So as a result of that, we'll see that whenever there is a change which has to be made to the software, so it would ask for a revaluation of the system specifications, and basically requirements and design documents are to be restudied to figure out what was the system specifications, what changes are to be made to the existing specifications, and how it is going to be done. So this is a spiral model which actually passes from different phases, which is the phase 1, which is specification, to the implementation phase, and then from there again to a validation and testing phase, and from there again to the operation phase. So there will be multiple releases, and you'll see this will be a cyclic process which goes from specification to implementation to validation to operation. And in different cycles you will see that changes would be implemented and the software evolution happens. There are when we talk about software evolution, and one of the challenges obviously is that especially in agile methodology we normally see that documentation is very limited. So if the team that is involved with software evolution, or the team that is doing the changes or the maintenance of the software may not get a very clear understanding because there is a lack of documentation, and may have to go through the system to learn about its different functionalities, and have to restudy the functional aspects, and then have to further redesign it and go through different other stages. So there are two other important aspects that we have to look at, and one is called software evolution. As I say, software evolution is a step that follows after software development. So after the software is developed and it is released, and after that when there is a requirement to change the software, that falls under the stage of software evolution. And software evolution normally needs to add new functionality to the software. It has to attain to some new functional aspects, which becomes the change requirements of the business, and That's why software evolution would actually cater to adding of new functionalities to the software. The other stage in the evolution is also called software servicing. Now, software servicing basically doesn't call for addition of new software requirements or new functionalities into the software. It is more targeted towards maintaining the operability of the software, how the software remains operational. It could also involve at times what is known as like refactoring of the software, not really adding new functionality to it, but restructuring the code, rewriting the code in some way to make it more organized, sometimes to make it more optimized, and that falls under software servicing. So software evolution, which would be adding new functionality to the software servicing rather, would pertain to certain code optimizations and restructuring of the code or refactoring of the code. When the code is refactored, it is actually sort of rewritten, so it becomes more streamlined, it becomes more structured, and it becomes more optimized. So that's basically a different set of stage, and it also falls under evolution, but obviously it's a different stage than software evolution. Final stage here is the software retirement. This is the final stage once the software has gone through software evolution and software servicing, and now the software has gone through substantial changes, and maybe in a change environment it may or it may not be viable to keep that software running, to keep that system running, and probably there will be a lifetime for a software, and there has to be some decisions taken that now the software has come to the stage of retirement, it cannot continue now. So as we say that the stage of a software system life cycle where it is in an operational use and is evolving as the new requirements are encountered, and that obviously forms part of the system maintenance, and it also forms part of the system evolution or software evolution. As we discussed earlier, that servicing is actually a stage where the software is required to be kept as operational, and it might need fixing the bugs, it might need changing certain things to adapt software to the new requirements, to the new environmental changes, but no new functionality is added. So no new functionality is added to the software. And finally, as we are looking at the retirement stage of the software, we would be looking at when the software has to be phased out, and when it is not viable to make any further changes, and obviously even after making the changes, the software business reliability, the business value of the software doesn't really improves. So that would be the stage when you would say, okay, it is time to retire the software. So evolution process depends on certain factors, and one of the factors is what kind of software is being maintained. So if a particular software is having a very high business value, that means it is being required by a large number of users, or probably a large number of businesses use it, and that would be a critical factor in determining whether the software needs to be maintained and how long the software needs to be maintained. The development processes also plays a key role in evolution process, as we see that in agile methodology there may not be a lot of documentation, and that could be one of the challenges to make changes to a particular software, because there's no proper documentation available. And probably it's also about, you know, what kind of design documents are available and requirement specifications that are available to the development team, and they have to be updated during the evolution process. So software evolution would actually require for different UML models to be changed as well. So that has to be looked at, and after analyzing those models and looking at the new requirements, you would figure out how the software has to be changed. The skills and the experience of the people involved, basically who are the people that are involved with the software, or rather are the users of the software, and the stakeholders would also play a critical role in evolution of the software. Here it would be appropriate to talk about certain kind of systems like legacy systems, which actually are very dependent on the requirements and probably the availability of the skills of the developers. And in legacy systems we normally see that they're developed in certain languages, programming languages, which are not as popular, and the skills for that language is very scarce. It could also be that the system, the legacy system, actually needs a specialized hardware, like it runs on mainframes, which are very expensive to afford and not viable in terms of business sense. So there could be many factors which actually decide the evolution process, and they are determinants of whether and how the evolution process would be handled and carried out. Okay, what are the change drivers for system evolution? It could be linked to the components that are affected by the change, or it could be certain factors which are going to impact the change of the software evolution. If you look at this, could be a situation when there's a major or an urgent requirement for the system to be repaired. So it's an emergency where the system repair has to be carried out urgently, and that could be one of the driving factors to urgently change the system. There could be a situation when there's a new competitor that has arisen, and as a result of that the strategy has to be changed, and that becomes a driver of the system evolution. There could be a bug or a system fault which could also drive the software evolution process. So change identification has to be done, and basically due to the change identification we might have to go for a change in the software, change in the system, and that forms the part of your software evolution. So it continues throughout the system lifetime, and the evolution, as I said, is at times an iterative process, because as the requirement changes, as the environment changes, certain evolution aspects arise. And so this table, this diagram shows you exactly different stages of change identification and the software evolution process. So first is your change identification process, and as you analyze that there has to be some reason for changing the software that would drive the evolution. So that would lead to a particular evolution in the software. So what could be the factor? As we discussed already, the factors that are driving the change process could be either business oriented, could be change in the operating environment, could be related to fault or some errors in the system, or it could be change in the hardware of the system. So these are some of the common reasons why change identification, a change has to be identified. And this is obviously the change identification process, which deals with identifying and acknowledging why the change has to happen and propose the change. Now after that, there has to be a change proposal which has to be further analyzed, and that has to be implemented through your software evolution process. So in your software evolution process, the change proposals, which is obviously a new set of document which is generated with the listing down all the changes that are required in the system, and software evolution process obviously takes care of these changes to be accommodated when the system is to be modified. So these are some of the factors that has to be looked at. Just like it happens in any software development life cycle, when you have to go through different stages of analysis and requirements gathering, and then eventually implementing those changes or implementing those functionalities into your software. Similarly, you have follow a cyclic approach here as well, where you have to decide over various different analysis has to be done of the change activities that has to be changed, release planning, how and when the new version of the software will be released. We have to consider the system implementation aspects of it, and also the cost and its impact on the end user. So these are some of the aspects which have to be considered while going through the software evolution process, and it obviously contains the stage of identification, change proposals, looking at and documenting the evolution process or the change process, how it has to be implemented, when the new software change software has to be released, and finally what you get is a new system. So your new system basically is the product of this cyclic iteration of changes. If we look at the software evolution process, the software evolution process can further be categorized into different other stages or sub stages. So first you have a change request, and from the change request you have to do an analysis of the impact of the changes. This could be the calculating the probably the cost effectiveness, or the doing the financial analysis of the overall change, looking at the cost benefit analysis again, looking at the developmental costs, or the cost that would be incurred in changing the software. Release planning, when the new version will be released, what different changes will be implemented, and then you have a final system release. Now these are some of the stages that through which software evolution goes through. Here the other aspects which has to be considered while you are looking at your evolution process, and basically looking at the release cycle of your software, and that would also be looking at aspects of whether what is the reason for this software change, why the software is being modified. So the point here is you have to justify the change, and you have to also quantify what different cost applications would be for the making the change, what would be the time frame of implementing this change, and by when you will have a new release of the system. So basically it could be due to fault repairs, it could be adapting to a new platform, which might be because of operating system changes or environmental changes in which that software operates, certain technological changes which affect the existing software functionality and its productivity. So either it could be repairing a bug which is basically removing the fault, or it could be adapting to a new environment, as we call it, as a platform adaptation, where you have a new operating system being released and you see that your software is not compatible with the new operating system, and as a result of that you might have to change certain configurations, you might have to change some certain dependencies, certain library files need to be changed, some other modifications have to be done to the software to adapt it to a new platform or a new operating system environment. So these are some of the system enhancements which obviously have to be made, and that forms part of the software evolution process. So if you look at the change implementation, you will see that there is a set of proposed changes, there is a requirement analysis which is done, requirements are updated, and at times the challenge here is if there is no enough documentation available, then it might be quite challenging for the maintenance team or the team that is responsible for making the changes into the system. Actually don't have enough material to look at the different functional aspects of the software, and they have to again restudy the software to understand what exactly the software functional aspects are and how they have to be changed or modified. So this is basically what has to be gathered. So this all comes under the analysis phase, as you can see, and finally in your implementation phase, when you have to implement these changes, so that basically becomes the process of change implementation would actually be very similar to your software development life cycle, where you have gathered the new set of requirements, and you have to update these requirements into the requirement list and eventually go on to implement this new software. Okay, so as you can see, this forms a new iteration, and it becomes a a new release as well, finally, once we have implemented these changes to the software. So it's an iteration of the development process, and that might lead to the revision of the system design and a new cycle of implementation. New tests have to be made. The new system has to be again tested, whether you do the regression testing or you do separate unit testing for the different modules that have been changed. Finally, all these have to be implemented and made sure that the software is in a functional state after you have done this. So basically, therefore the main challenge that arises, and that mainly arises if the original system developers are not the team, are not responsible for the change or for the maintenance of the system or evolution of the system, then it becomes quite challenging for a new team, because they have to in the first stage they have to understand the system itself, and after they have understood the system, then they have to make the changes to the system and further do the implementation of the new system there. So this is quite a challenging process for a new team. So in the program understanding phase, where you have to do a new set of requirements gathering and requirements analysis, so it's a challenge to understand how the program is made, how the program is structured, to understand and to learn the new aspects, and to rather study the functional aspects of the system and also see how the proposed change might affect the overall system. There may be situations when there's a requirement for making urgent changes to the system, and this could be for various reasons, like there's a serious system fault and you need to really repair it for the system to keep on functioning. There might be change in the system requirement, system environment, like an operating system upgrade has happened, and because of that the system is not functioning appropriately. There could be a competing product coming up in the market, and to beat that release you may have to quickly make some changes, or develop some new functionalities sometimes and implement those functionalities and release the system before them. So these could be some of the compelling factors which could bring to a you may have to skip certain steps of a typical software development life cycle in order to achieve a quick release of the system. So emergency repair process could actually involve a urgent change request, and as a result of that there has to be a quick analysis of the source code. You have to modify the source code and deliver the modified system on a very urgent basis, on a very short, relatively short release cycle. And as the reasons specified earlier, this could be like a very emergency situation, and as a result of that this has to be done in a very rapid form. Comes one of the driving forces of software evolution as well. Agile methods and evolution. As we know that in agile approach we have shorter cycles of system development, and there are quick releases as well of the system. So evolution basically in that case is just a continuation of a developmental process of agile. So basically after the system has been developed and deployed, the next cycle of changes in the system might be categorized as a system evolution. So in agile methodology, system evolution or software evolution is an integral part of the process. How this can be efficiently achieved is through automated regression testing. So whenever there is a change in code, and that obviously happens as part of software evolution, so you have to do a regression testing. Now if you go for a manual regression testing, that would be costing a lot of time and resources. So automated regression testing is a way to go, and it's very suitable for a system release or a typical system which has been developed as part of agile approach, and automated regression testing can speed up the process for that system evolution. Therefore, if you are using a agile methodology, you'll probably see a new set of user stories being generated as part of your software evolution process, and the changes will be documented as new user stories. Now in this typical scenario, there could be a conflict between the process of software evolution if the development team actually used agile approach, whereas the evolution team is unfamiliar with the agile method and they are using the traditional approach, like plan-based approach. So in that scenario, evolution team actually expects a detailed documentation in order to understand the software, whereas that doesn't exist in the case of agile processes, in the case of agile methodology. So in that situation, and it could be the vice versa as well, it could be that the development team actually used a traditional approach, whereas the development team or the evolution team rather prefers agile approach in implementing the evolution of the, or rather changes to the system as part of the evolution process. So that could be a challenge, and in order to handle the situation, the evolution team might have to again develop a new set of test cases from scratch, and the system may require a refactoring to implement any of the changes and to make it streamlined with the agile development process. So that could be an additional requirement placed because of that typical scenario when you have a difference in approaches between the development team and the evolution team, and if there is a mismatch, that has to be then rectified and handled by using this mitigation strategy. So basically that would involve creating new set of automated tests, and it may also legacy systems. Legacy systems are basically older systems, and many a times they are systems that have been developed probably in the time period of 1960s, 70s, and 80s, and they rely on languages and technology which may not be very much available in today's scenario, or might be difficult to procure. So legacy software is normally dependent on older hardware. So you might be having this particular legacy system which runs on a particular server, or probably run on a particular mainframe computer, which also has a very typical operating system environment, which is very much different to today's modern day operating systems. And it obviously has associated legacy processes and procedures. So legacy systems are not just software systems, old software systems, but they also bring in a lot of history or other socio-technical issues along with them, which could be the requirement for a specific hardware, a specific set of software and library. So this diagram actually depicts the dependencies of a legacy system, and as you can see in this case, you see a particular legacy system would need a particular set of support software and set of specific application softwares, and obviously a set of different business rules and business processes, and they are all integrated into this application software. The examples could be certain systems which have been there from quite a long time, which could be your air traffic control systems, which could be traffic control systems, which could be certain systems which are like financial systems which have been used from a long time, like insurance and other different sectors, and they run on specific application data, and that application data is also very old. So you can see that here the dependencies are even greater, and this application software also run on a specific set of hardware which may be very difficult to find and which very difficult to procure or maintain in today's scenario. So that's basically are the challenges towards a legacy system. Different components of a legacy system, as I said, determine how and when this legacy system has to be changed. So if it is written for a hardware which doesn't exist anymore, then obviously that may lead to either scrapping of a legacy system, or rather modifying the legacy system, changing it to a level where you may have to rewrite a lot of functionality, and a lot of dependencies have to be looked at when you are trying to redeploy that system into a new change environment. Support software, what kind of support software it needs, and is it available, and what are the challenges on that side. Application software, so that actually provides the business services or the certain programming languages, certain programming routines which are written in a particular language, which probably is not very popular these days or is not widely supported. So you will probably find a lot of assembly level applications. You'll probably find applications written in COBOL and in Fortran, which tend to be more of like older, the first generation and second generation languages, and are not very widely supported, and there is no skill set, and there is no trained or professionals, much trained professionals available in today's scenario. So these are some of the challenges, and that could also be one of the driving forces for deciding to change a legacy software or to replace a legacy system if certain availability of resources is very scarce. Application data that is processed by this system could actually be very much optimized, because in olden days, in the the first and second generation of computer systems, the memory was very scarce. So probably you are very much aware of the Y2K problem, year 2000 problem, which basically arose due to optimization of memory while storing the dates. So there you only had two spaces, or rather 2 bits, to store the year. And if obviously the year was 2000, which was approaching, and that time you can relate to that problem today, like you are in 2020. Now if you only have 2 digits representing that year, you'll probably write 2020. Now what that 20 signifies, whether it signifies year 2000 or it signifies year 2020, which is today's year, current year. So it's sometimes your computer system might won't be able to resolve this problem, and might actually result into bugs and errors due to trying to resolve whether it is the old year or a new year, and that basically causes the problem. So application data may be very much optimized for these legacy systems, and which may be inconsistent and sometimes uncompatible to the new systems, to the new databases. So there might be a requirement of reorganizing the data or recompiling the data to make it suitable to be hosted on new databases. Probably that would also sometimes involve hiring up specialists who do the data migration for you, who has to basically study the old data and see how it fits into the new scenario, the new system, and probably have to develop new set of programs to modify the data, which is known as data parsing. And sometimes you have to call the specialist to do the data parsing, where they will write certain routines, certain programs to convert the data from the old format into the new format that is being used. So that becomes quite challenging. So what are, as we mentioned about business processes, so these are the business processes which are in use, and they are designed to support the legacy systems, and they may be constrained in their functionality that they provide. So business policies and rules, these may be sometimes very old in the legacy systems, and they may be constraints to carry out into a new business environment. So the use of legacy application system now might be very much embedded into the old set of policies and rules, and the challenge would be obviously to sometimes look at what and how these legacy systems can be changed, to what level it can be changed to out what. So while we are talking about the challenges that are associated with legacy systems, that the systems basically are written in very old languages, and you don't find programmers to support and to maintain these kind of systems. They might be running on certain mainframe computers, which also have lifespan, and they will be at one stage also retiring, and you need new systems to run them. With all these challenges, why we don't just replace all the existing legacy systems? And the problem is that some of these legacy systems have been there for so long, and the user base for these legacy systems has been so huge that it might affect so many users to replace the existing legacy systems. Plus, the cost of replacement of the legacy systems could also be a major factor. If the usability of the legacy system is huge, then the cost of probably if you replace it with a new system, probably the new system will be easy to maintain and will be having low maintenance cost compared to the old legacy systems, which basically needs very specialized professionals, and they are very few these days, because there's a dearth of professionals who basically have the skill set of working with legacy languages like COBOL and Fortran, and the legacy systems which run on different platforms like AS400 and different other platforms like IBM AIX platform, which is a platform which is derived from Unix systems, and very specialized professionals or specialists basically are able to work on this platform. But it's a platform which basically, as I said, needs specialists to work on, and it runs on mainframes. It's not easy to find the manpower for this platform. So basically, probably, and the platform, this AX platform actually runs one of the most critical systems, whether they are in a financial industry or whether they are in different other kind of very real-time support systems, critical support systems, and all that. So these systems basically have have been there for a long time, and it's not very easy to replace these kind of systems. Also, you have to look at different other aspects while you are replacing them, and the experience rather shows, because the systems have been developed over so many years and they have been so optimized that replacing this system is not a easy piece of cake. And most of the time, experiments or other efforts to replace the systems have rather fallen into disarray, because as I said, the systems have been overly complicated systems, and the efforts to replicate these systems has been either very costly, or they have been rather unsuccessful, because as I said, of the complexity of these systems. Some of these systems actually involve very intrinsic business rules, and these business rules have not been documented effectively. So to replicate that becomes quite a difficult task, and these are some of the challenges while replicating the existing legacy systems. So as I highlighted, there are different challenges while replacing these systems. But obviously, since they have been there, probably a stage would arrive when you have to replace them. But when is the right time? That is very difficult to determine. We discussed about the challenges that some of them are written in programming languages that are very old, first and second generation programming languages. So you don't find people to maintain them or to modify it, because the programmers of these languages are not easy to find today. They don't come with a good system documentation, so probably they have been changed or optimized over a longer period of time, and they have become so complex that it's not easy to understand and document all the business processes that they are involved in, and to change that. Many of these systems are highly optimized for memory utilization and execution speeds, and that's why they have been modified to run on certain platforms, which is not easy to replicate with the new operating system requirements, with the new operating system environments, as well as the new hardware which is available today. So that makes the challenges. The other one is also the data that they basically work on and the file formats they work on are also very old, and it's not at times easy to modify and to adapt that data to the new structures and to the new databases that we have today. So these are some of the challenges, apart from obviously talking about the business processes, which are very complicated. Application softwares that it uses at times is also very old, very legacy systems. As we said that it uses certain languages which are not today much in common use. The platform and the infrastructure software basically is also legacy platform, and therefore the systems which have been running on mainframes and the operating system that it supports are not very easy to replicate. The hardware, as I said, also it's basically not very much manufactured in today's time, and the whole developmental and deployment strategies have changed. So now we are rather than going from a centralized systems, now we are actually moving towards distributed systems or web-based systems, which offer functionality as through cloud or through web interfaces, and where the certain functionality also come as software as a service or as web-based applications. So it's not very easy to really transit from a legacy system to a new age system, and depending on the user bases that they command, the different other systems that they are so as we talk about this, the legacy system replacement is risky and expensive, and as the factors that I have already mentioned, sometimes the businesses continue to use the systems. They cannot simply replace the system so easily. So system replacement has been a very risky affair, and due to the factors that we discussed, there is not a full documentation of the system specification, very tight integration of system and business processes, because the systems are overly complicated, very complex systems, and they are very tightly integrated with their environments, with the operating system environments that they work with, and they are highly optimized for these operating system environments. So that poses a challenge to simply port this system or move the functionality from the old systems to the new ones. Undocumented business rules, that's the other challenge that you have. And the new software development obviously sometimes are not very compatible, and to implement them could be also very difficult and rather over budget to really consider all these factors, and to move environments is not going to be easy. So legacy systems, as we saw with these factors, that it is very expensive to change, and the number of reasons that we have specified earlier as well, that they basically use very old legacy programming language, and the style is also very procedural, so no consistent programming style, use of old programming languages which very few people understand and they are proficient in, inadequate system documentation, the system structure degradation, since these systems have been there for years, 20-30 years, they have gone through so many changes that there have been so many modifications that the basic system structure has been degraded to in some cases. So it's not very easy to follow that structure and to replicate that structure. As I said, they are very highly optimized in terms of memory and in terms of storage. So therefore, it's not easy to replicate them to the new systems, and it's not easy for the new programmers to understand the logic and to replicate that logic into the new systems. Data errors. The data, as I said, is very sometimes stored in rudimentary formats, in file formats which are not supported anymore these days. So duplication and inconsistency can be a big problem to tackle when you are changing these systems. So the organizations that rely on legacy systems, they must choose a strategy, how they would and when they would really move from the old systems to the new ones. So they have to make an informed decision when they can scrap the old system completely and modify their business processes to change to the new system, or whether they must continue to maintain the old system, which obviously is like a white elephant, which is not easy to maintain, not easy to gather resources to do that maintenance and to carry out the evolution process, and to re-engineer the system to improve its maintainability. So these are some of the challenges that the company has to face, and they have to decide and make an informed decision when they can, and when it's the right time to actually make the transition. So when it is viable to replace the old system with a new system. So the strategy chosen would depend on the certain factors, and one of the factors is something called the system quality and the business value. So you have to balance these two aspects here to figure out when would be the ideal time to make the transition from old system to the new system, or when it will be profitable to move from a legacy system to the new system. These parameters are to be considered. System has to be replaced or scrapped. So who does the assessment and who are the stakeholders in this assessment? Basically, these are the system end users. How many people or end users are using the system? That is one of the determinants of making a decision. Business customers, the line managers involved, IT managers and senior managers. So all these stakeholders have to be taken into account, taken into confidence before use of the system. As we already discussed about the number of users, so if there is a small number of people who are using, then probably it has a low business value. So that's one of the parameters, and that doesn't make a very strong case for business for the continuity of that system. Business processes that are supported. If a system has a low business value and it basically results in inefficient business processes, then obviously that's one of the other determining factors whether the system has to be replaced or it has to be scrapped. System dependability. If a system is not dependable and the problems directly affect the business customers, so the system has a low business value again. The outputs of a system. So if a business depends on the system outputs, that means the business is producing certain reports or it is producing certain data, and that data is critical for the business to run, to operate. That means that system has a high business value and it cannot be justifiable